Hi, I'm Jim Grouch, and I'm an engineer specialising in mathematical modelling and simulation of complex processes. And in this series, How Things Work, I'm taking an engineering and simulation and analysis approach to society. How does society work? Is it what we want it to be? And how could it be changed? In a previous video titled Introduction, I introduced the book Operator's Manual for Spaceship Earth by Buckminster Fuller, an eminent engineer. And in this video, I want to add another book to the reading list. And the book is called Emergence by Stephen Johnson. And I hope you do read these. So, what is emergence? Well, emergence is the outcome, often incredible, from the interaction of simple rules being followed by many simple but independent doers of things. And doers of things may be ants, water crystals freezing to form snowflakes, spots forming on the skin of a leopard, or people driving past a speed camera. And when the rules are not visible, the observed outcome can be amazing. And when the rules are invented or engineered to implement a plan, and the plan is a good one, the emerging result is truly inspiring. So, back to Stephen Johnson's book, and one of the examples that he provides some detail for is in describing the behaviour of ant colonies. When we observe the behaviour of ant colonies, considering the colony as an entity, such as a society, we observe what happens, what appears to be great governance. Resource allocation is optimised between the needs of exploration for food, transportation of the food, defence, waste disposal, and even optimal location of the waste facility, considering the environmental effects on the colony. And this warrants studying. How does the ant society achieve this? Who is this ideal Prime Minister? Well, we don't speak ant, and so we have to observe and measure and apply scientific principles to study this behaviour. And what we find is that ants are simple. They are autonomous entities, each acting independently with about 5 behavioural states or activities. Each ant produces a chemical, like a taste or a smell, that indicates the activity that it is busy with, whether it's exploration, transport, defence, etc. And as they are carrying out their individual tasks, ants repeatedly bump into other ants and poll or survey the number of ants that are doing different tasks. Then any individual ant can change its task or behaviour to do what is not adequately represented by others for the good of society. And so emerges from a simple rule applied across independently acting individuals an optimization of a society. It consists of the model consists of known behaviour, simple rules, and results in stable society. But what would happen if a defence lobbyist worked out how to make a panic chemical and went around broadcasting crisis? Or equally, a pacifist started broadcasting with chemicals, nothing to see here. Or what if a fast food manufacturer produced a chemical sensor modifier to increase the proportion of food gatherers? Well, we could model this and predict the emergent result on society. And of course, this kind of modelling of society behaviour is very, very common and is best known probably in games, which is one of the greatest behavioural analysis tools that there is, which we all have access to. Much the same as much of social media is effectively used for general and individual behavioural analysis. Okay, so if we had this model and we looked at the emergent predicted result for society and we didn't like the prediction, we could ask our government to explain the current rules and we can make changes in the model and calibrate it, improve the calibration. And if after checking the calibration, the predicted and the observed results of what's happening in society are not good, we could issue a please explain to our government, or maybe even consider a behavioural modification request in the next opinion poll. So, as we continue preparations for starting this exercise of mathematically modelling how things work in society, we're going to have to consider rules and policy. So I hope you'll join me again for more of these videos because I think this is going to be fun. Thanks for your time.